Welcome to the lecture session on modified Euler's method. This is another method in order to find a solution of initial value problem. So consider the initial value problem, that is dy by dx is f of xy with y of x naught is equal to y naught. We need to find y at x1, that is x1 is equal to x naught plus h. We first obtain y1 of 0 by using a Euler's formula, which is given by y1 of 0 is y naught plus h into f of x naught comma y naught. Here the accuracy is poor. In the case of Euler's formula, the value can be improved to the accurate value by using the modified Euler's formula. So what is the modified Euler's formula? And each of the succeeding approximations is better than the preceding ones. Now let us look into the modified Euler's formula. It's given by y1 of 1 is equal to y naught plus h by 2 into f of x naught plus x naught y naught plus f of x1 y1 of 0, where y1 of 0 is obtained by Euler's formula. Next, y1 of second iteration. So it is given by y naught plus h by 2 into f of x naught y naught plus f of x1 y1 of first iteration, that is obtained from the modified Euler's formula in the first iteration. This value need to be substituted here. Rest all the formula will be same. Fine. Now let us look into the problem. So only the two iterations it is required. Next, if it is required, you can again change in the place of y1 of 1 as y1 of 2 to get the improved better value. But when we fix the decimal places up to 4 or 5 decimal places, within y1 of 2 we will be able to get the answer. Let's see the first example. Using modified Euler's method, solve the initial value problem given by dy by dx as x plus y. The initial condition is y of 0 is 1 at x equals to 0.2 by taking h as 0.1, that is the step value is 1. Now when the step size is 0.1 and we have to find x as 0.2, so we need to do it by 2 stages. So we compute y of 0.1 first and use this value to compute y of 0.2, like we have done in the Runge-Kutta method of fourth order 2 stages problem. This is. So let us look into the first stage now. In the first stage, x naught is 0, y naught is 1. That is given as the initial condition. And consider the given function, that is the initial value problem dy by dx is equal to x plus y as f of x y. In the place of x and y respectively, if we substitute x naught and y naught, we get 0 plus 1, that is given by 1. And x1 is nothing but x naught plus h, that is 0.1. So h is equals to 0.1. Now initially let us apply the Euler's formula, which is given by y1 of 0 is y naught plus h f of x naught y naught. So that is y naught value is 1 and h value is 0.1. F of x naught comma y naught, which is obtained here, is equals to 1, is substituted. On simplification, we get y1 of 0 is 1.1. Okay. Now we will apply the modified Euler's formula, that is given by y1 of 1 is y naught plus h by 2 into f of x naught y naught plus f of x1 y1 of 0. This y1 of 0 is obtained by using the Euler's formula. That value is 1.1. Now let us substitute these values. So y0 is 1, h is 0.1, so it is 0.1 by 2 times of f of x0 comma y0 is 1 plus f of x1 comma y1 of 0 is substituted with x1 and y1 of 0. Fine, that is 0.1 plus 1.1. This on simplification, we get 1.11 as the value of y1 of 1. Now, let's go for the improved value of y, that is y1 of the second iteration. So, when I apply the next modification, the formula will change as y0 plus h by 2 into f of x0 y0 plus f of x1 y1 of 1. Here the same formula except y1 of 0 is replaced with y1 of 1. So 1 plus 0.1 by 2 into 1 plus 0.1 plus 1.11. On simplification, we get the value 1.110, which is same as the previous value. So we stop at it. That is y of 0.1 is given by 1.11. This is the first stage. Now we use this as the initial condition in order to compute y of 0.2. So in the stage 2, we consider x0 as 0.1 and y0 as 1.11. So f of xy is x plus y and f of x0 and y0 is given by 0.1 plus 1.11, which gives us 1.21. Therefore, x1 is x0 plus h, which is given by 0.2, then h is 0.1. Initially, we apply the Euler's formula. It is given by y1 of 0 is y0 plus h into f of x0 comma y0. That is, y1 of 0 is given by 1 plus 1.11 plus 0.1 into 1.21, which is obtained earlier. On substitution and simplification, we get 1.231. Now, by using the modified Euler's formula, the formula is given by y1 of 1 is y0 plus h by 2 into f of x0 y0 plus f of x1 y1 of 0. That is on substitution, that is 1.11 plus 0.1 by 2 into 1.21 plus 0.2 plus 1.231. That gives us on simplification 1.2436. Now, in order to get the second iteration, that is y1 of 2, that is nothing but the second modified value. So, the formula is given by y0 plus h by 2 into f of x0 y0 plus f of x1 y1 of 1. Thus on substitution 1.11 plus 0.1 by 2 into 1.21 plus 0.2 plus 1.2436. This on simplification we get 1.2427. This is the final answer of y of 0.2 on second stage. Next question. Using the modified Euler's formula, solve the initial value problem. dy by dx is x plus y square, where the initial condition is given by y of 0 is 1 at x is 0.2 by taking h is equals to 0.1. Carry out the two iterations in each step. That means two modifications we need to do at each step. And here also x is given by 0.2 and the h value is 0.1. Therefore, we need to compute this value of 0.2 by two iterations and the two stages. We need to compute y of 0.1 and use this value to compute y of 0.2. First stage, by data, x0 is 0 and y0 is 1. f of xy is x plus y square. Therefore, f of x0 y0 is 0 plus 1 square, that gives us 1. And x1 is x0 plus h, that is 0.1. So h is 0.1. By Euler's formula, we have y1 of 0 as y0 plus h into f of x0 comma y0. That gives us 1 plus 0.1 into 1, that is 1.1. By modified Euler's formula, we have y1 of 1 is y0 plus h by 2 into f of x0 y0 plus f of x1 y1 of 0. That gives us 1 plus 0.1 by 2 into 1 plus 0.1 plus 1.1 the whole square, which gives us 1.115. Now let's go for the second stage, second iteration, that is y1 of 2. So y0 plus h by 2 into f of x0 y0 plus f of x1 y1 of 1, where y1 of 1 is given by this 1.115. Therefore, on substitution